So hi, yes, my name is Mykalin Jones. I'm the founder of Astro Tutors. My background is in astrophysics, thus the name. I don't teach astrology like a lot of French people seem to think. I hope that depresses you as much as it depresses me. I have been teaching 4 years, but I specialize in teaching Python both to children and career switchers in individual and group settings, and I do write curricula as well. That's one of my favorite things to do. So I wrote my talk teaching children Python while it works, and this talk because I've noticed some interesting expectations from both parents and newcomers to the industry when they first start coding. I've also noticed some really interesting promises coming from the for-profit education industry that annoy me. So we're going to be talking about misconceptions, methodologies, strategies for success, and what we can do as a Python community to support learners, and basically just both for children and adults this time. So Monsieur Nicolas actually asked me this question last time in Limerick. So why is Python the best language to start with? So I wanted to start with that. And I think the best reason is because of the friendly and helpful community. I really just love the Python community. I think we're really here for each other. There's so many wonderful, great resources online, free resources. It's free and open source as well, and we encourage collaboration in the open source community, which I think is spectacular. It's also close to natural language, which not only makes it easier to start with and learn, but it also makes our work easier as programmers for sure. So the other thing is I've noticed there's a misconception in the general public that it's for teaching to code, but this is not true. Of course, we all know this. There's so many uses. There's extensive libraries written in faster languages that we can rely on. There's the PyData stack, which I rely on a lot due to my work in data science, of course. Extensive machine learning libraries and everything. But the other thing I've noticed is you don't really have to switch careers in order to benefit from learning Python. I've seen a lot of people use Python in their current job to expand the scope of their current job, of course. So an example would be learning how to use pandas or learning how to use Excel beans if you work extensively with Excel. So I think programmers are also human, summarizes why Python is the best language to learn most effectively. So he said, when you read from the Zin of Python, it says there should be one and only one obvious, preferably only one obvious way to do it, which is why we have 3 different versions, 12 different ways to install them, and 80 different frameworks for the same thing. Easy. But what does it actually mean to learn to program? Why should you start? There's a lot of misconceptions about programming, learning to code, and what it's actually going to do for you. People don't understand what they don't know and are often taking a stab in the dark by just listening to what seems to be common advice. Oh, everybody should learn how to code. I've decided to summarize this general confusion in the best way I know how, memes. So to the left, you'll see what my mother wishes I would do. So in general, people tend to have maybe a glamorous or just sort of unrealistic expectation of what a job in tech really looks like. This probably comes from the media mostly. Another thing I've actually seen several companies use to advertise their boot camps and other services is, do you want to make a 6-figure salary? I have 3 degrees. I'd love to. Where am I money at? We're just going to go past this. So, I mean, they aren't wrong, though. And then, of course, this is really what we actually do. I really work with my students that they don't freak out when they see an error. Errors are our friends. Bugs tell us what's going on. Stay calm and use your tools. Becoming a programmer isn't about knowing everything. It's about developing problem-solving skills and the confidence to tackle hard problems we don't yet know how to solve. That's the excitement of it, and that's also where most students actually realize it isn't for them. That's okay. Of course, because I'm going to be talking about children today, I have to mention what I frankly find to be a bit disturbing, which is this trend where there seems to be an emphasis on wanting to have super genius children, like prodigy children to show off or something. I don't think that's every parent, of course. Parents just want to set their children up for the best possible future as well. So there's a balance there, of course. But we're going to start off today by talking about realistic expectations, methodologies when working with children, and also just when it's appropriate to start and what you can do in the meantime if they aren't ready. So some things that concern me, you hear a lot as advertising material, we should start children coding as soon as possible because it's like learning a language. I hate this. It's a wonderful analogy while you're teaching, if you're teaching to people who enjoy language learning, because we know how much work it takes to become fluent in another language. That's wonderful. But you could also say it's like going to the gym. You get better the more you go and the more you practice, right? I also don't like this because I see a lot of adults posting on different social media platforms like, is it too late for me to learn how to program? Because they think, oh, they've pruned the ability to learn to program because it's like learning a language, right? And they can't pick up on the phonemes. Like, we don't have phonemes in coding, don't worry, guys. So it's really confusing. You're not too old to learn to code. My oldest student is almost 70 years old, and he's having a great time. There's just other marketing aimed at convincing parents to put their kids in coding classes ASAP. And then, of course, I have to deal with this thing I like to call the parental-induced Dunning-Kruger effect. So what I get is parents who get really enthusiastic about teaching their kids to code. They sit them down, they're doing tutorials with them, and these children think, oh, I know how to code. I've learned Python, right? And so they're actually quite hard to teach because they think they're far more advanced than they really are, because they don't know what they don't know. And the worst part is the parents also want to believe their child has also learned this, so then they'll be like, oh, why are you going over the basics with my kids? It's like, sir, your child didn't know what the variable was in this code, so that's a problem. And then the worst, most disturbing part is always children who are afraid to admit that they don't understand. So I'll form a relationship with a child over a month. The parent will finally leave the room, and I'll ask the child, so are we getting stuck somewhere where we're lost? And they'll look down very sheepishly, look for their parents at the door, and they go, I don't understand anything. And I go, great, let's start there. It's totally fine. And then the last thing that really does concern me is also unnecessary screen time. So I think that's something to talk to your pediatrician about before sitting your child down in front of a screen and being like, all right, tiny, tiny child, you must code for you need a job. Like, so the last situation I really don't think we want here is what we have on the left over there. So forcing kids into coding classes that they aren't interested in just doesn't work. They're going to get a bad taste in their mouth for it, and they're not going to want to do it later. Pushing kids to do projects they simply just aren't ready for. So following tutorials online and then assuming they understood anything, it just generally isn't a good idea. Start with very, very basic things and work your way up. A linear path that assumes they will remember literally anything. I'll go over my pedagogical technique extensively in this talk. But yeah, no, we review every single lesson. And what's infinitely helpful to me as a teacher is if parents can try to review on a regular basis with the kid, which they don't seem to want to do. They come once a week, and then they go, oh, why isn't my child progressing? It's like, well, they do this 1 hour once a week, and it's a lot of confusing stuff for them. And then, of course, removing the play from learning. I try to keep things really fun and really lighthearted with my kids, and even with my adults. I want them to enjoy. So the really big problem is I think we're fixated on teaching children really advanced topics, but I'd argue we're asking most of them to run before they can walk. So you'll see here, if you're really interested in like child development and brain development, you can do some wonderful things while they're still young. So early childhood music, ECM is what I put there, I couldn't fit it on, is absolutely excellent. You can start from day one, and then of course teaching them natural languages while they're young is a great thing to do. But really what I want to emphasize is we should be focusing on literacy, mathematical background, typing skills, creating inquisitive minds who aren't afraid to not know something, being able to work with others, so sports are great for that. I'm not into sport ball, but they have their purposes. And then other activities just in general are really great to incorporate apart from this. But I do really want to emphasize typing, math, logic. I get a lot of students who still have difficulty reading and just with basic computer skills, and adding that into learning how to program is just very difficult. So how do children learn, and how do I structure my curriculum based off of that? So it's absolutely okay to spoon feed children. Children absolutely just learn by observing absolutely everything from day one. They're just looking around. And so I try to keep the frustration level less than or equal to their frustration tolerance. This is going to range based off of age and also just neurodiversity. So anything that affects your prefrontal cortex, executive functioning, dopamine levels. So if my student has ADHD or something, that's also something to take into account. by keeping the frustration level low, by just starting off with Google Colab, I don't freak out my students as well as far as the install goes, because that always just terrifies people if their first issue with programming is, I can't even get Python working on my computer. So we just start off with Google Colab. People always ask me. Mimicry is good, so I do this, you do this. I do this, you do this. That's also a perfectly valid pedagogical technique. Exploring, random play is essential. So I love it when they ask all these, what if you do this? Well, what if you do this? Well, why did you do this? And if you don't have the tolerance for that, teaching's probably not for you, but or parenting. So, you know, I'll do something and they'll say, well, what would happen if you put in 1,000 into that? And I'll go, well, same thing, but 1,000 times. But, you know, I don't say it out loud. I go, oh, let's find out. Oh, I don't know. You can do things to stimulate their senses. Turtle is great for this. So I can literally show them how a for loop works by having a turtle dude run around on the screen and change colors, and they love this. So people often ask me, well, how would you engage with that turtle? Turtle is a wonderful pedagogical tool in Python. And then just feeling safe, encouraged, and having adults who are excited about what they are learning. My students who do the best often have parents who aren't programmers come to the classes with them and are just totally stoked to be there, and that often goes fantastically. I am going to skim this a bit because it takes up quite a lot of time, but I do want to emphasize no programming should not replace basically language acquisition and language classes. A lot of parents seem to come with this idea that learning Python's like learning a foreign language. There's a lot of similarities, but like I said, it's like learning anything difficult. So no, it's not really like learning a language. It affects different parts of the brain, actually. I can't find a one-to-one correlation with like pruning. It's just not quite the same thing. So those sounds that you can't hear anymore after a certain age, that's an example that I don't see anything in programming that's related to that. So also, really, once learned, programming doesn't actually rely on the language regions of the brain, which I think is really interesting. So how about while learning? What I do want to emphasize is that language ability does impact your aptitude overall. It is a very strong indicator of just how well you're going to do pretty much at anything. They've started looking at reading tests more than the math tests, for instance, at the Harvard Physics University, like to enter grad school there, actually, which I thought was really interesting. Raising your kid bilingually has a lot of excellent benefits for them as well, including better focus, increased cognitive flexibility, and it's correlated with mathematical ability. So basically, just to summarize here, should we teach students in their own language is a big question I like to bring up. I'm really passionate about translating pedagogical materials. So some languages are actually better suited to explaining mathematical concepts. This has been shown, and I think that's really interesting. And I often wonder, well, is there a better language to explain programming? So something I often think about is, in Irish, actually there's a certain built-in mutability. So in English we say, I am sad, which is a bit dramatic, like, oh, I'm sadness itself. But in Irish you would say, tá brón orm. So sadness is just on you, it'll be off you later. And this is just one of many examples where it's a very flexible language. So people see problems differently. They pick up on problems, what even is a problem, and how to solve those problems based off the languages that they speak. So I actually think not only is it interesting to see how we would explain topics in programming, but could we potentially learn something from code switching and from explaining things in different languages. So I'm really passionate about discussing how, utility as far as, more people speak this language shouldn't really guide what languages we're willing to teach people in. So I think it's important to encourage language diversity. It's a huge passion project of mine, and I'm happy to discuss with people after the talk if you're interested. But in general, I'd like to encourage parents to teach their children a different natural language while they're young, in addition to other things you can do to encourage brain development. So we're going to talk about that a little bit more. What can you do around the home if they aren't ready for programming classes yet? So you can provide puzzles. This is wonderful. Children seem to just absolutely love puzzles, and if you leave them around as something that they can do, they get used to doing these. It doesn't involve screen time, and they just really love them, and they're also very beneficial. You can also use real-life situations. So here we have some cake batter and some cupcake tins. So you could say, while I have batter in this bowl, I can keep scooping cupcakes out. Or for each slot in this cupcake tin, I want to fill it with 1 scoop, right? So you can explain things like how you would think of them logically, algorithmically, and that's a really good way to get them processing in that way. Show them some simple code when they are ready for screen time, and have them ask what-if questions, what would happen if you changed this, see if they're just interested in it. My parents are musicians, so when I was a little kid, they would just sit me on the piano bench with them, and I just remember being fascinated just watching them. So if you're wanting them to be a bit interested in it, just exposure is actually totally awesome. But, allowing them to follow their own interests, they can, continue to develop their brain and develop new skills that you won't really understand how it's going to help them later on down the road. But I have noticed that when people are allowed to follow their own passions, if it happens to be programming, that's great. When they're allowed to follow their own passions, though, they always find something to do with it. So don't worry, your kid doesn't have to learn to program now. They'll get a job, it'll be all right. But when are they ready? So they show genuine interest, they ask what-if questions, and try things if you show them some simple code. They're ready to work on typing, or they're already okay at typing, and some math background definitely helps, also just fluency with reading. 9 years old is okay, some 8-year-olds are ready, but I'll be honest, I prefer to start 14 plus. I do have a lot of requests for 8-year-olds though, so. But why should we teach children to code? So I've gone on and on about, oh, they're not ready yet, don't do it, it's fine, I also like money, though, so. And of course, I do this for a living. They are information sponges, absolutely. I think also they just have less stress in life, so trying to learn this as an adult when you're also in a career and a job, maybe you have kids, it's a lot harder. Your brain is just less stressed and it can focus more and enjoy it. It will be useful for them later in life, most likely. It will also teach them resourcefulness, self-reliance. It can teach them teamwork. So if they're on any sort of club at school, they can be on a programming club or a science club, math club, anything like that, and use it to supplement that. It teaches them logic and problem solving, of course. And I really like to point out that it's a great way to supplement or reinforce coursework. So, through my physics training, we did a lot of plotting and computational methods and all that stuff. So I'd argue most students would benefit from coding lessons. But the question is, of course, how? How are we going to implement this, and how are we going to make sure that people are actually benefiting from it, as opposed to giving them one more topic that they're just overwhelmed by? So what do I focus on? What do I think is important to emphasize when you're first starting off? It ranges depending on age, but my main concerns are always logic and problem solving, developing confidence in finding answers, so getting your tools together and just giving it a go, and not just, I don't know how to do it for me, which is a lot of my students do it first. I'm like, give it a go, try it out. Self-motivation, why are you doing this? What would you like to do with it? Creativity as well, so not just in solving problems, but also just coming up with projects to do. So see an issue and then try to solve it in a creative way. Good commenting is really important to me on a spiritual level. So I once received some code from a professor where the only comment was, this should be self-explanatory. Now, a lot of physicists work in C++, by the way. So I think that's why we all switched to Python. It's a trauma-based behavior. But readable code with sensible variable names is something that I really enforce with my students. My personal pedagogical philosophy relies on what's called the spiral method. So basically, you start with very simple things, you increase the difficulty over time, but constant revision whilst combining it with new content is the main goal here as they approach mastery. So every session, I start with a recap of what we've done last time, and I try to reincorporate everything and go back around. Basically, my students repeat the basic curriculum more than 3 times before we really move on to more complex things, because they will be building on top of all of that. But the challenges become slightly harder, and they work a bit more independently over time. I like to start each new section with a demo as well, so that's sort of spoon feeding, where I just show them what you can do. So here's a simple little rhyme that we do, and it counts down for them. But basically, I start each of my group classes and working with individual students with an overview of what we'll be learning in the basic curriculum. So the first day, they seem to all really enjoy just watching me code. It really takes away the stress and gives them a good general idea of what we mean by programming. A lot of people just don't know. And then my students will ask a lot of what-if questions, and I'll show them what happens if we do that. So they like this, where we plug in 100. Sometimes they want to plug in 10,000. I'll be like, all right. And then we switch to guided mini projects, which are usually text-based games. This is where I tend to start getting complaints from parents. No, I will not be teaching your 8-year-old who can barely type and doesn't know the basics of Python how to build a Django web app. Like, it's just not going to happen. So eventually, students do that happens. Eventually, students do start to pick their own projects, though, and that's really exciting when they get to that point. But one project they seem to really, really love is this choose your own adventure game, which is how we learn conditional statements. That's really quite fun. And then we'll review with short syntax questions as we sort of learn the syntax, and then the next lesson we'll start with it. So I'll do like a fill in the blank sort of thing. What's the variable here? That's a question they often can't answer, and that's all right. What's the data type? So, oh, that's an integer, yay. Have them go back to their old code as well, and explain it to you. That's also great to pull it up from the previous session. Make the variable names better if they name them something silly, add some comments in, but I like to have them comment their code if they didn't do that the first time, and so then they go, oh, geez, it would have been really helpful if I commented this last time, because I have no idea what this does. So I'll sometimes take their code and show them how I might make it better, but it's better if they do it themselves. It just depends on how frustrated they are, of course. So then we go on to like puzzles and stuff, especially once we've done functions. I do really like this totally free website called CodingBat.com. There's just a bunch of test functions so they can see if their code is running properly, and there's a bunch of really cool sort of logic puzzles that they have. So this one is, we want to make a row of bricks that is goal inches long. We have a number of small bricks, 1 inch each, and big bricks 5 inches each. An American wrote this. Return true if it's possible to make the goal by choosing from the given bricks. So this is a really fun little puzzle that you guys might want to solve for fun later. And then we just go on to arbitrarily more complex projects that tie together more subjects. So going back to the adventure game, because they really love this one, I'll maybe have them add in a game loop. It will like check to see if the person is inputting valid inputs or something like that, and then say, oh no, that's not a choice, pick again. Maybe review F strings or something like that, because those are cool. Basically, now that we know more stuff, how could we make your old code better? So some other examples would be like they print a code cake using like multi-line strings, make Mad Libs, random stories, and then I really enjoy this turtle racing game, which we do later on. And even my teenagers really like Turtle. I know I get that question sometimes. Well, I'm teaching like 15-year-old boys. No, they love Turtle. It's great. And then for students that are around 14 plus, my students who are nearing high school are usually the ones who benefit the most from the basics curriculum, because it doesn't take that long for them to grasp the concepts and also know exactly what they want to use them for. They often have an idea of what interests them, and then we go from there. So they may be interested in web apps, building games, or in some sort of after-school science or engineering club. I know that that was my case when I was younger. And also, my students in America, they do have to take like standardized tests where they have this calculator, and I think it's really cool. They can actually program in Python on it and do their plotting with Python. It's not very convenient. They can do small little things, but you can actually write your program on your computer and then put it on there. So that's pretty nifty. One of the reasons I'm really interested in this is because the calculator, you can get it used for cheap, if not free. And I do come from an area where students really just can't afford computers. Maybe they don't even have smartphones at home or anything like that. And so maybe this is a potential solution for people who wouldn't otherwise have the ability to learn a bit of programming and stuff. So I think that that could be really interesting. So now we're going to move on to adult career switchers. I would like to point out I always technically forget that I am an adult career switcher because I started programming during my degrees. But overall, I was basically told by people to go into STEM growing up in Kentucky because I could get a good job and make money, but they had no idea what that took. So I really emphasize with that when people come to me and they're like, oh, I don't know, I just kind of want to switch careers and somebody told me to learn how to code. So this really brings me back to the image that we started with here. People tend to think it's either something totally unattainable or difficult, or they think it's something like some sort of get-rich-quick scheme. I wish. A lot of people have started on some sort of train where if you can't learn to do something, it's also just because of bad teaching. So there's this sort of thing like everybody can learn to code. Everybody should learn to code. And I'm not going to say that you can't. I never discourage my students, but I do try to give them cheap tests up front before they sink in a lot of money. Because I'm a bad business person. And just see, do they actually genuinely like it? So there's really this in-between where career switching is difficult. We're well paid because it's a hard job, usually. Some of you are slackers, I know it. Coding isn't what you think it is, probably, before you get started for a lot of people who didn't come in from this background with like their parents or something. And I think that the for-profit education industry needs to be held accountable and practice ethics when taking people's money and offering them a supposed better life. The fact is, the people I see to be most successful have a clear answer to this question. What problem do you want to solve? They have realistic goals, expectations, and timelines for how they're going to achieve what it means to them to learn to code, because that's such an umbrella sort of thing to say, oh, learn to code. To do what? When it comes to teaching adult learners, you've already seen my pedagogical technique, and I probably should have said up front, yeah, that's pretty much what I use for adults as well. I do take more guidance from their professional goals, of course, but yes, I use a very similar system for teaching adults, especially coming in from a non-technical background. And there's, of course, a huge emphasis placed on the student being able to independently answer questions so that they can feel comfortable during a technical interview. I try to give them a lot of materials for that as well. Something I have noticed is a lot of adult materials are just far too frustrating up front. So a lot of my students have complained about expensive boot camps that they just couldn't follow or get anything out of, and that's when they hire me, is just to pay me more money so that they can even get the certificate they paid to get, because they need a lot of support getting through it. So this prompted me to send out a couple surveys, actually, which we're going to be discussing for the most of the remainder of this talk. I wanted to know if maybe I've just seen the worst side of the industry, which I'm kind of seeing as true. It's more optimistic than I expected. Or if people are having this experience as well, and you also see some of that. So hopefully you can read. Yes, okay. So I sent out a survey with 40-ish questions. So I was amazed that I got 32 valid responses. I know that that's not a large sample size, so this is more like an interview with 32 of my best online friends I've never met. 71.9% of these people are learning Python. And we actually had a pretty even split, with 50% respondents being female, 47% being male, and about 3% identifying as gender neutral. And you can see that the majority of them were in the late 20s to maybe 40s range, early 40s range. 55.2% of respondents also had coded during their degree. So I do want to point out the distribution up here of the amount of people who did a master's in a STEM field. So 46.9% of these people have had some sort of job before, so that's what I considered had been hired during this analysis when I split people up. This could include some sort of small contract, but actually 43.8% of my respondents had been successful in getting their first full-time job in the industry. So I got to see opinions from both sides, people still trying to get that job and people who had been successful switching careers. Obviously, I did have some expectations looking into this, so some confirmation bias is absolutely inevitable. But I do want to point out that you see people who did their master's in the STEM field and had ended up getting a paying job at quite a high amount. Those seem to be the most successful of the people that I surveyed. But we have a lot of people who have an undergraduate degree in a non-STEM field who are still trying to get jobs, and then we also have people switching in from a STEM degree who are doing quite well. It does seem that you have a bit of a better chance if, amongst the people I surveyed, if you did a STEM degree, of course, which makes a lot of sense. They're probably the people who also did programming in their degrees. So basically, between my survey and my many, many students, I've compiled a list of issues that career switchers face. Maybe you haven't thought of all of these, so I wanted to bring them to your attention. My first one is a lot of people are trying to learn to code, and they don't even have access to a real working computer. I get a lot of questions, I can't afford a computer, how can I learn to code on my phone? So I'd really like to encourage people, if you have an extra computer sitting around, I know that sounds really like, oh, if you have an extra computer sitting around, but I actually know a lot of you do. If you can donate it or sell it for a cheap price or help people find good refurbished computers, then that's absolutely wonderful. So I'd like to encourage people to think about doing that. People are also trying to switch careers with time constraints, children, and a current job. The other thing is, it turns out it isn't as easy as they thought, because advertising is worded like, learn to code, like as if that's, yeah, just do that. And I see a lot of people doing it not because they're passionate about it, but because they feel like it's the best next step, and that is not really well correlated with success in my experience. I hate to bring up aptitude as well, but some people just really aren't cut out for it. I'm never the person to tell them that. I'm always very, very encouraging. I don't think it's my right to say, oh, you can't, because personally, coming from my own experience, people have told me, oh, I don't think you're very good at that. And then I just go and study really, really hard, and it's like, oh, no, I could figure it out. I just had to find a different way of having it explained. But I do a few cheap tests for people to see if they really enjoy the style of thinking that you have to develop in order to be a good programmer. Also, a lot of people are coming in with a horrible first experience. That was me. They might have difficulty picking a resource that works for them. They might have found it for a class or a boot camp or something that just really was not geared towards people who had zero expertise at all. Lack of accommodations for disability is something near and dear to my heart. I have contacted several online learning resources that take money for certifications because many of them, in fact, as most of them, don't actually offer extended time testing, which a lot of these are American companies. And so if you are not ADA compliant, I will find you and I will send you a politely worded email. If you haven't found community support as well, I've noticed a lot of these companies that don't specialize in Python education, they don't know to sort of encourage people, hey, you're learning Python, go to community events, go to PyCon, go to meetups. I think it's absolutely essential. And then also there's people who are learning, they're doing really well, but they just don't know how to get that first job. So we're going to talk about those. The first thing that I want to point out is motivation. Yes, a lot of people are motivated by money, but one of the things that I was really pleasantly surprised by in my survey is that almost everybody, all but one person who mentioned money, they also mentioned another reason why they were switching. And for a lot of people, it was about personal challenge and growth. They did want work-life balance. Something that really upset me was American teachers switching because they were afraid to go to school anymore because of reasons. Then a lot of people, it was actually a lifelong dream, which I thought was incredible. And then we did have one person who said that they were a Ukrainian refugee, and this was an opportunity for them to have a good job. And I just thought that that was amazing that we could do that for them. So a couple of things to consider. How do you know that it's for you? These three things are by far some of the biggest factors that I see that really sort of weed people out and make them go, ooh, I don't really like this. I get a lot of people who they don't like math, they don't like reading. I think reading, we all have to read, like a lot. I read articles every single day. So I think it really helps to enjoy reading. And notice I asked, do you like it, not are you good at it? Because people tend to be a bit more honest about whether or not they like something as opposed to whether or not they can do something well. And then finally, I did ask just about typing proficiency. You'll notice I was lazy and did not fix my axes. So nobody responded lower than a 3 for typing, 3 being average, according to my prompt. I was very specific about how I wanted them to fill this out. So, consider your aptitude, consider your personality. People seem to all be skewed towards the higher values on all of these, as far as we tend to like to read, we tend to like math a bit more, and we tend to be pretty good at typing. So these are all skills you should work on if they're not your favorite thing. Basically, just get in and just try it. Really? So try to solve something tricky. Don't just copy and paste a tutorial and go through it. Really try to hit against a wall and see if you can stick with it. And do you get that rush when you figure it out? I think that that's a good sign that you're on a good track. Also, just sanity check. I do get a lot of gamer bros who think that programming is going to be like playing video games. I don't know where that comes from, but it's not true. Watching out for your well-being. Switching careers is really, really intense and difficult. So come up with a realistic time frame. How much can you sink into this? How long are you willing to take? Are you willing to take a bit longer if you have to keep working and everything? I don't encourage my students to just quit and jump into switching careers because I have had students who are doing really, really well. They're very, very close to that first job, but they have to go back into their previous job because they just can't afford to not be unemployed anymore, which makes a lot of sense. So a lot of my people who answered this, 34.4% said that they were unemployed or underemployed, and then a few people said, I'm not sure, but maybe, which I'm going to assume is I don't have enough money. And then also something that I think is really, really important is we really need to remove the stigma around getting diagnosed with ADHD. I get a lot of students who come to me and I do notice, oh, have you maybe followed this path of getting a diagnosis? And that just changes absolutely everything. And that's one of the first things that we focus on. And as a teacher, just across the board with math and physics, and whenever I'm teaching standardized tests as well, I help students get the accommodation they need. Because of the name of our medications, people are very wary about it, but one of the best things about ADHD is it is the most treatable psychological or neurological disorder that exists. I think 97% of people respond to medication, and so it's really unfortunate to see it when people don't get that treatment that they absolutely should get. I want to just emphasize therapeutic doses are very, very different from any sort of dose that is recreational, and there's a reason why these medications exist. If you have any questions about ADHD, people always come up to me after my talk, and I'm happy to answer them, but there's also Russell A. Barkley. I think he's over at Stanford, and he does some wonderful YouTube videos. So, getting started, we've talked about getting set up, but now how are we going to actually, get you started learning and then get you the job? So, plan your work and work the plan is what I've always told my students. It's just 3 steps. Have great study habits, do the work, and then get the job. Oh, done. I do like to emphasize having great study habits, of course. Behavioral activation is a method from cognitive behavioral therapy that's well validated. So if you're one of the people, whether you're struggling with neurodivergencies, depression, anxiety, or you just have a hard time being organized, start off by trying to schedule in 2 times this week that you sit down and work. The next week, schedule out 3. The next week, schedule out 4. What you'll find is that by forcing yourself to do things, the more you do that, the better you get at doing it. You can also measure how you are progressing, so you could use input or output. I let people choose, but basically you can go by the hours you put in as a goal, or do you want to get some output? You want to gain a certification, you want to produce a certain amount of projects. So that's up to you. How are you motivated? Bullet journaling is something really, really great. Unfortunately, neurotypicals kind of hijacked it, and we're like, oh, let's make it all artsy and fancy. It's supposed to be a very simple planning method, so I recommend looking into it. And then body doubling is something that people often don't know about. It's usually a free service where somebody will just call you, a random person in the world, and you'll sit together and have a productivity session together, and I think it's wonderful. So doing the work, we're going to go through each of these points, but in general, people just need to pick one good resource and get started, just get started. Later on, you can diversify your learning resources. You can focus on solving hard problems and writing Pythonic code. This is really important. Get started on your portfolio right away. This is something that I see people missing out on. Get involved in the community, find a mentor, and then try to share what you know. So preferred methods were the first thing that really interested me in making this survey. So I actually sent this out to the Codecademy online Facebook group. It's actually fans of Codecademy. They're not officially associated. And this isn't very interesting because obviously they all mostly preferred the online self-paced ones like Codecademy. It's a Codecademy group. What I found particularly interesting was the entire lack of mentorship. There was one person who had a programming mentor or said that they did. And I allowed people to pick multiple options just to get an idea of what were all the resources that they were using. And it just seemed like there was an entire lack of mentorship on this platform. Well, not Codecademy, they do offer some things, but just within the Facebook group. So then in my survey, I sent out, I did ask about preferred learning methods. I asked people to fill out all the ones that they use, but this one is showing what their favorite one was. I asked it in 2 questions. And what I found interesting is really how much people who had a paying job relied on person-to-person contact, be it via a live person like a coding mentor or getting that from a boot camp. Also, people who are hired seem to really like to use YouTube tutorials. I don't know if that's a certain self-reliance that comes with people who are successful in this industry, but it's interesting to point out. But yeah, I do find it really interesting that people are sort of relying on these boot camps quite a lot. It seems to be one of the most preferred ways to learn how to program. And I do see varying degrees of success with that, of course. So it's just interesting, and I think that there's maybe something we could learn from this as far as a community and how we could support learners by just offering mentorship. So selecting quality learning materials is something that's really important. I don't want students just, spending $13,000 on a boot camp that promises them a placement afterwards, and then when you read the fine print, you find out it's an unpaid internship, and that's the statistic they're using. So, really pick something that gives you a clear learning path. Something that emphasizes PEP 8, I really like to see that included. I did ask the question, if you're learning Python, have you ever heard of PEP 8 or the Zen of Python? And 25% of people who took my survey did not know what that was. And I found that a little bit upsetting, because remember, over 70% of these people are learning Python. So, some materials are really not so good as well. So when you're watching YouTube tutorials, it is good to bear in mind some of these people are learners themselves. I think it's fantastic to share what you're learning on social media, or to share with your friends, or to do a little bit of teaching, maybe be a teaching assistant at a boot camp if you can, something like this. But don't put a disclaimer, if you will, like, oh, I'm a learner, this is something I did. So I saw this basically where they were using a for loop to make a new column in a data frame, but you really don't want to do this. Pandas supports doing math directly on columns, so really you could just do this entire thing in one line. That's an example of something that I see that a learner might try to do, but somebody who knows what they're doing is probably going to do it that way. So it's just good to bear in mind. You really want to use several resources to make sure what you're learning is the best way to do things as well. I like to see for companies to emphasize portfolio building as well. Emphasis on community participation. And then I like for people to remember to select your certificates carefully and with reason. Is the company well respected? Is it like AWS, Anaconda, something like that? And don't just do a bunch of basics of Python certificates. Pick your certificates with a reason. This is why this learning path is so important. Getting out of what a friend once termed as tutorial purgatory is, I think that's something that's really, really important. Do projects that mean something to you. Companies can tell if you just put some mini project from an online tutorial on your GitHub, and they're hardly impressed. So they really want to know, what have you been doing with your time since you've been trying to switch careers? And I think that this is really important. Have you done some open source projects? That would be amazing. Can you volunteer to nonprofits? I don't necessarily know if I agree with volunteering for small companies. Don't let people not compensate you just because you're starting off. If you have certain skills that are marketable, you should be fairly compensated for them. And certainly don't do work for free for a promise for a job. I've seen that happen. And there's some people who will take advantage of you, and they'll keep asking you to do work and then never compensate you for it. And that's not normal. It's not normal to receive something as a pre-interview thing that's really you're doing work for the company. So teach what you're learning. Please just say that you're a learner, but I think that this is wonderful. And then also you can offer to translate materials. If any of you have interest in helping me translate things and put stuff online, I'm always open to that, just as a voluntary thing, because a lot of what I do, my curricula are all free. So getting that first job. Get active on LinkedIn. Oh, and by the way, because I just jumped into working for myself straight off the bat, I wanted to ask somebody who's maybe a recruiter about this. So huge thanks to my friend Josh over at Foxley. He's actually going to be making a post about this really soon. So watch out for that coming out. So we had a nice discussion about, well, what are people looking for to get that first job? So get active on LinkedIn, be active in the community, do talks. You can absolutely do talks as a learner. Keep your GitHub up to date. I say law because I'm a hypocrite. Do mock interviews. You can actually watch mock interviews on YouTube, and I think that that's really helpful. You can do your leak code problems, and one of the things that Josh pointed out is if you have 60% of the requirements on a job posting, just go for it. Just go for it. And just remember, there's not just one way to get your first job. I have seen people get jobs starting from an internship, and I think that that's fantastic. What I would ask is that the community consider giving more options for that. So if you have the possibility to create those roles, go ahead. If you are a contractor and you can subcontract to somebody who's learning, that's fantastic. Community is absolutely indispensable. The fact is you went to university, you had way more resources at your fingertips for several years, including experts, fellow students, paid subscriptions usually, research opportunities, constant feedback from professors, and you built the connections you might be able to rely on to this day. Independent learners coming from, say, the service industry or something don't have any of that, or at least not nearly to the same amount. So if you can mentor, absolutely go ahead and mentor. Here are some links. Is insufficient, by the way. Try to schedule regular times to meet with people and offer some training. So you guys can check out my slides if you want some suggestions. I just leave sort of a script for how to problem solve if you decide to be a mentor. And, because a lot of people come up to me with a lot of frustration. So here's a little bit communication for programmers. But anyways, I just wanted to leave you guys with this sort of Zen of Python education rough draft. If you want to read it over, I'm curious, do you agree? What would you add? So I'll just read it. PEP8 exists for a reason. Refer to the actual documentation and not some random website. Simple explanations are better than complex. Complex is better than complicated. You will have to repeat things. We can't all be Dutch. If you know the Zen of Python, you get the reference. If you still don't get it, just give it a go. Try it out. Short, frequent lessons are better than long. Long sprints have their place, though. Programming is not a spectator sport. Get your hands dirty. Error messages are our friends. Meetups are one honking great idea. Let's do more of those. Thank you.
Thanks, that was an awesome talk. A quick question about tools like ChatGPT in learning. Sorry to be that person, but I've seen particularly like adult learners maybe jump in with ChatGPT, start getting some results really quickly with something. I wonder, do you see that as like a valuable tool in experimentation or kind of a risk of like just maybe getting that frustration when you make that first step and can't really get further?
Yeah, so that's such a good question. I didn't get the chance to put it in my talk, but I do encourage my students to try to work it out by themselves using, Stack Overflow or something like that and trying to figure things out by Googling and everything. I just assigned a project to a student, actually, and he obviously used ChatGPT for the whole thing. And I said, hey, in a programming interview, could you explain to them how to do that? And he was like, no. And I was like, so how did that help you, right? So when you're trying to learn things, you have to balance that out. But if you're getting really frustrated, ChatGPT is obviously a great tool. Learning good prompt engineering, good idea, right, in today's society. But overall, I think that if you're going to be using these tools, an emphasis needs to be placed in Python education to write Pythonic code, writing idiomatic Pythonic code. And so if you don't know about that, then that could be a problem because ChatGPT isn't always Pythonic in its answers. Thank you so much.
Thank you so much, Mykalin.